This is a walkthrough of the code that you wrote in the previous lesson, the 36-line code to study PyTorch, vector search, vector databases, sentence transformers. The 36 lines also includes the data that we're using for the input, as well as comments. In our study here, we are building a game, and we are using the vector database in a visual novel to analyze the dialogue of the characters in the novel. However, there's a real reason to use vector databases, which you may encounter more and more. Something called RAG, or retrieval-augmented generation. I'm first going to explain why the vector databases have become more and more popular. Imagine you have an interface like ChatGPT, but it's using enterprise data, meaning that you don't want to put this thing public. It's running locally within your company. One of your staff or potential your customer asks the interface a question. The question is then converted into an embedding. When you search on the question with the dialogue or the content that's already in the vector database, you'll get a relevant set of documents. Maybe it's customer records, support transactions, these type of things. That set of embeddings, the response from the database, is then sent to the LLM. The LLM generates the response using the retrieved content from the vector database, and you get your final answer. But first, let's congratulate you. In building this 36-line application, you've already built a real application that can use a vector database, PyTorch, transformers, similarity search, and much more. You now understand how to convert the text. We have our text is the game dialogue into numerical vectors using embedding. You also have configured the vector database. We're using Facebook AI similarity search. And you can now perform the similarity search. You've also learned some key terms in machine learning and vector databases. And we're going to review these 36 lines multiple times. Similarity search using our vector database is using the keyword search on the index that we generated right there on line 24. As you saw from the last example, instead of a keyword matching that's common in SQL, the similarity search will find things that are similar. For example, battle and fight will be roughly equal. Your application takes the sentences as pieces of text. Then you generate the embeddings using something called a PyTorch model. So the model here is made from sentence transformers, which is a package that you import. Model name is all-mini-lm-l6-v2. It's just an identifier for the model. And you convert it here. Then you store the vectors in the database. And then you can now search for the vectors that are close to your vector query. And it'll return the similar terms. All right, so this is the data. One of the words in the data is the word fight. And the query here is there was a battle. So the top search result is Aki gets into a fight and runs away. If I change the query into someone drank Japanese sake, my expectation is that it would come out something like this, right? Because the Japanese sake is a form of alcohol, and it seems the most relevant term. I'd also expect maybe this thing would come up as the second most similar, because eating and drinking are similar. So for the query, someone drank Japanese sake. This whiskey is most similar, and Aki ordering a bowl of ramen would be somewhat similar because drink and eat or getting the food are kind of similar, and Japanese sake and ramen are also types of food that you consume.